Not sure why. You don't have any test scheduled, so I was expecting at least 80% attendance. Yeah, I guess it's Friday, so not Friday, it's Thursday today. My counterpart is giving me wrong information here. Okay, a quick recap then. We at the very first lecture on Tuesday, we covered transportation planning. It wasn't a very long chapter, but some very important theory that we covered under transportation planning. So I trust that you went through maybe the presentation, the recorded presentation or the notes, went through Moodle, had a look at tutorial 1, 2, and 3 and identified some of the questions that were already covered in the first 3 chapters or 3 modules, namely transportation planning, and then we looked at transportation systems, the first 2 modules. So today we are looking at the third module, module 3, that covers driver and vehicle characteristics. And if you could recall at the last lecture, I did say that I could spend a whole semester only on driver and vehicle characteristics. But obviously that is not the intention of this course. Give you more an appreciation of the various topics, various areas, various modules, and certainly more detail will be covered at the honors level. So module 3 is quite an important module. You will see that your calculations stem out of this module under transportation systems. And some of the calculations is known to you, it's not new to you, and I'm referring specifically to side distances, calculation of design stopping side distance, or safe stopping side distance, whichever terminology you are familiar with. So it's important that you go through your TRTA 201 notes, get familiar with some of the stuff, because there's nothing stopping the examiner slotting in a 2 or 3 mark question on something that you've covered, like stopping side distance. So do a bit of homework on your own. I'm sure you haven't thrown your files away or your notes. Perhaps you have them electronically, I'm not sure. So go through some of the information pertaining to side distance. So coming back then to module 3, you will find that with driver characteristics basically split into 2 areas or elements. And the more important one is the physiological elements. So we're looking at the physiological elements, and when it comes to the physiological elements, of course, one of the most important physical factor is vision. So if you can't see, then you shouldn't be on the road. Yeah, we could debate that with the modern technology, where vehicles can drive you without you even lifting a finger. But basically, in terms of first principles, you should be able to see to be able to drive. And when we talk in terms of vision, a few important aspects pertaining to vision are highlighted on that slide. The first one being visual acuity. And that basically determines the size of detail your eye is able to resolve. In other words, able to see. And it's a given fact that this visual acuity diminishes or decreases with age. So as you get older, your eyesight gets worse, and hence your visual acuity is not as good as when you were a young man or a young person. Don't want to be sexist. So visual acuity, eye movement. When we talk in terms of eye movement, how quickly can your eyes jump from one object to another object? Fixation. So that's also a very important point to take note of. And you'll find when you do go for an eye test, some of these factors are tested. Depth perception is another very important one. And some research have shown that we have many pedestrians on our roads, for example, that crossing our roads don't have very good depth perception, in a sense that they cannot judge the distance and speed of a vehicle approaching. That is why they take their chances of crossing the road. Obviously, you know the end result of that. So depth perception is very important. Peripheral vision, in other words, trying to see outside your clear cone of vision, which is your 10 degree on either side. So how much can you see outside that? Okay, periphery. Visual attention, yes, that is something that many drivers forget to take notice of. And I'm referring specifically if you are a driver and you're traveling at a very high speed, it's very common that you tend to focus ahead of you when traveling at high speed and forget about right in front of you. And therefore, when a pedestrian, for example, tries to cross a road right in front of you, you don't even see the pedestrian until you slam into the pedestrian. So that is something that many of us are not aware of, the visual attention aspect. In terms of color, sensitivity to color, yeah, many of us are colorblind. You will find many drivers are colorblind. They don't see a red signal light. They only see a green light. So even if it's red, to them it's green and they cross over. That is why we have so many collisions at intersections. You know, your intersections are points of conflict. So perhaps you may have done this at 2A, or I'm not sure if any of you covered 3B. Last semester, I gave you a little tutorial, a little exercise to do, and I said to you that draw 3 intersections. Okay, one road crossing another road. Simple sketch. And the first intersection, allocate your movement in both directions. So both intersections, you have traffic moving in both directions. And then you plot your points of conflict. Vehicles crossing over, vehicles turning left at the intersection, vehicles turning right at the intersection, where it conflicts with opposing traffic, oncoming traffic. Plot your points of conflict. Then take the second intersection, and now the second intersection, take one approach one way. So one of the two approaches make one approach one way, whilst the other intersecting approach still remain at two-way. Okay, vehicles in both directions. And repeat the exercise. Plot all your points of conflict. And finally, with the third intersection, then look at both the approaches one way, right? Intersecting one way. And again, plot your points of conflict. And you'll be surprised to see how your points of conflict decrease from the first intersection to the second intersection, and then also decreasing to the third intersection. That is why we say your intersections are the points of conflicts where the possibility, you have a very high probability of collisions at intersections, and therefore one needs to look at traffic management measures, techniques to try and reduce or eliminate accidents at intersections. And also your capacity, we spoke about capacity on Tuesday, a reduction in capacity at your intersections. So yes, sensitivity to color, glare vision, recovery, and you can do a little exercise with regard to glare vision and recovery. If you're in a room and at night and you suddenly switched off the lights, complete darkness, how long does it take for your eyes to adjust so that you can maybe able to see certain objects in the room? And vice versa, if you're in a dark room and suddenly you switched on the lights, how quickly will your eyes be able to adjust to see objects in the room? So that's what we're referring to, the recovery in terms of from darkness to light or light to dark. Deterioration and defect, self-explanatory, like we mentioned, it increases with age as you get older. Visual deteriorates, sight. Night blindness is also covered there. Pedestrian vision also in terms of poor vision, blind pedestrians attempting to cross a road. So these all then fall under your physiological elements. So with physiological elements, we also have other senses, like for example, hearing, perhaps maybe not as important as sight, but certainly contributory. The horn of a motor car, okay, hooter for motor car. Other senses you can see a few listed there, like kinesthetic or kinesthetic, whichever way you want to pronounce it. Perhaps came across an advert, a cigarette advert, that said whether you say Pall Mall or Pall Mall, you're still smoking, or rather still reducing yourself or smoking yourself to death. Okay, that was not the actual advert, but you get the point in terms of the pronunciation. And then, of course, and with that, if you are, for example, in a dark room, you should have the sense of where your arms are or where your legs are. So that falls under the sense of kinesthetic or kinesthetic. Vestibular, you should have the notion of whether you're going up or down. So position yourself on a lift, and if the lift is going up to a certain floor, you should have that sense that you are going up and not down. So that falls under the vestibular sense. So all that falls under the physiological elements. And then you have the psychological elements, which is obviously less defined, but certainly contributing. So with psychological elements, you can see a few listed, like motivation. When we talk in terms of motivation, a lot of driving habits change depending on the purpose of the journey. So for example, if you were traveling to maybe the Suncoast Casino, your motivation would be certainly different to, for example, if you're traveling to campus. And that could also have an impact on your driving behavior, your driving habits. Intelligence, yes, certainly some degree of intelligence is needed by a driver to be able to understand, to be able to adjust to traffic situations, to adapt to traffic situations. So intelligence also plays a role or a part. Learning process, that comes with experience. So how many years of driving experience you had, you develop skills, and you have a better understanding, a better ability to respond to situations. And then we have the emotional factors, and with the emotional factors, we have three highlighted. First one being attentiveness, and that deals more with, for example, distraction from maybe non-traffic events. So if you are driving and you see a beautiful jogger on the road, on the side of the road, your eyes are then focusing on the jogger instead of the road or the traffic or the vehicle in front of you. So your attention span is then reduced. And other factors, if you have company in the vehicle, chatting with your colleagues in the vehicle, or you may have some problems, worries, all that then has a direct impact on your attention. Attitude towards regulation is there's some people that have no respect for traffic laws, some have little respect, some obey all traffic laws, abiding to traffic laws. So that comes with your attitude. Impatience and anger. Certainly, if you have a driver that's very impatient, will tend to drive at higher speeds, more than the speed limit. Dangerous driving, as we say, overtaking on a blind drive, sharp bend, weaving. So these all fall under the emotional factors. Yes, with maturity, one would tend to mellow and become more observant. Certainly, research has also shown that younger drivers tend to take more chances, drive at higher speed. Well, case of showing off. What's the output? What's the torque on your vehicle? How quick you can get from A to B or 100 meters in X number of seconds. Doing the wheelies, you all know that, all your young drivers. Conditioned response, good or bad, so comes with habit. Sometimes they say habits are bad to change, especially the bad ones. So you live with it and you demonstrate that in your driving. Conditioned response. And yes, one must take into account, must recognize that we have different individuals with different aspects, different capabilities. So those are some of the factors that's even incorporated in your design, where you incorporate a fairly high factor of safety to take cognizance and account of some of these differences. So those fell under the psychological elements. One must also consider the environmental conditions could affect human behavior, land use, undulating terrain versus flat roads, built up areas versus rural areas, high density areas, low density areas. So land use plays an important part. So for example, if you were driving in a built up area, maybe in the CBD where there's many pedestrians trying to cross traffic signalized intersections, then one would expect to be more attentive on the road compared to maybe on an open road, freeway situation. You tend to be more relaxed traveling at a particular speed. So these are points that fall under the environmental conditions, and the others are also self-explanatory. Weather conditions, poor weather conditions, wet conditions, misty conditions, where you have fixed facilities for traffic. For example, you have a roundabout or a signalized intersection, stop condition, yield condition. So all that has an impact in terms of your driving behavior, capabilities. Traffic stream and its characteristics, I think that one you should have covered at the 2A level as well when we talk in terms of capacities and factors affecting capacities. So, and I think on Tuesday I gave you a brief explanation on that as well, where you have various conditions. Your traffic changes from hour to hour during the day. So morning, you have your morning peak where you have high volumes of traffic. Your concentration is on the vehicle in front of you. The vehicle behind you is concentrating on you. So there's heavy force flow conditions. Could even be unstable flow conditions where traffic is moving at fairly high speeds, but heavy concentration between drivers. Okay? And all you need is maybe a winter granny in that traffic proceeding to do her Pick n Pay shopping and reduce speed. That could have a ripple effect, and you could be then down to force flow conditions and even a traffic jam situation where all vehicles are then stationary. But that very same road, maybe at midday, maybe now, could be free-flowing traffic where you can maintain high speed, you can overtake if there's more than one lane or 2-3 lanes in each direction. So you can see all these falls under the traffic stream and its capacity and its characteristics, how it varies from hour to hour. And that is why, for design purposes, we base our calculations on the DHV, the design hourly volume. So that gives you a good indication in terms of how your traffic volume alters from hour to hour. Reaction time, again, is nothing new. You've covered aspects pertaining to this in safe stopping side distance, safe passing side distance, shoulder side distance. So you can see it's based on the PIEV theory, which basically describes the 4 components of reaction. Although we use the word reaction here, to be a little more specific, it's more the PR meaning perception reaction. And you all know that with side distance, stopping side distance, it's based on your perception reaction time, one of the elements, one of the factors, one of the values that you use in your calculation. You can see the PIEV, the perception, intellection, emotion, and relation. So you can see from that when you are, for example, traveling on a road and you suddenly see an object on the road, you realize that braking action is required. So there's a certain time interval that has passed from the time you perceive that object on the road and you realize that braking action is required. That's what you refer to as your perception time. And then you step on the brake pedal to try and stop your vehicle. So in other words, you react by stepping on the brake pedal. And then that's your reaction time. And very often this time that we're referring to is given as a combined time. And it's loosely termed the reaction time. Okay? And this reaction time can really vary You can see there's a range from 0.5 to 4 seconds. And there's a lot of factors that influence this reaction time. Varies from driver to driver. It could be due to age, could be due to tiredness, fatigue, alcohol content in the body, drugs. So there's various factors. Seating arrangement of the vehicle. There's a number of factors that falls under vehicle characteristics. So there's various factors that one will have to consider and take into account. But for design purposes, we normally use a standard value. And I think by default, you have used a value of 2.5 seconds. So if you're given a question, then by default, you will base your calculations on 2.5 seconds. And 2.5 seconds is a fairly high value. It does incorporate a high factor of safety in the calculation. Therefore, you will see that the values you obtain, the safe stopping side distance or the safe passing side distance, are fairly high values. You obviously wouldn't need that much of distance to stop your vehicle, but like I said, it does incorporate a high factor of safety. So yes, you can see modifying factors at the bottom there, where there's mention of fatigue, alcohol, time of the day, weather conditions, and all that will then have an impact on your safe stopping side distance. So with the safe stopping side distance, safe passing side distance, like I said, the onus is on you to go and do a quick recap of your 2A notes where you covered some of this information. And to jolt your memory, I've put in a slide here where you can see some information on the stopping side distance. And like I said, there's nothing stopping the examiner giving you a 2 or 3 mark question pertaining to stopping side distance. So with stopping side distance, you can see the basic formula that you did cover in the previous transport module. You may have used the terminology design stopping side distance to calculate the design stopping side distance, which is DSSDO, for example, or you may have used SSD, safe stopping side distance. So whichever abbreviation, it doesn't really matter. And so in summary, you can see that your safe stopping side distance or your design stopping side distance is based on what we refer to as the reaction distance or perception reaction distance, which is given by the perception reaction time, and by default you have used a value of 2.5 seconds. That's a TE in the formula, multiplied by V speed, and the formula is based on the design speed. So the design speed will be given to you. And again, you can see then that incorporates a high factor of safety, because you shouldn't be traveling at the design speed. You should be traveling at a speed slightly lower than the design speed, very close to what we refer to as the operational speed, which is in the vicinity of 0.85 of your design speed. So that's your D1 then, and the D2 then is the braking distance. So remember, I mentioned to you a short while ago, you're traveling on a road, you see an object on the carriageway that poses a danger, and you realize that braking action is required. And in that time, you have covered that D1 distance, your reaction distance or your perception reaction distance. And then you step on your brake pedal, and your vehicle does not stop immediately, irrespective of how good tires you have, whether it's ABS braking system or whether you have Pirelli tires or Michelin tires. The vehicle will still travel a further distance, D2, before it comes to a standstill. And your braking distance, D2, then is based on, again, the speed of the vehicle. Well, design speed is based on the design speed. It's based on the gravitational acceleration, which is a constant. Okay. It's based on the frictional coefficient between the tire and the road surface. And with the frictional coefficient, it could, the condition will be specified. So in other words, whether it's wet conditions, whether it's dry conditions. If the examiner did not specify whether wet or dry conditions, then you would immediately consider worst case scenario, And worst case scenario is wet conditions. So if the values are not given to you, then a table will be provided where you can read off the frictional coefficient values corresponding to the various design speeds. So that's your coefficient of friction, and then I in the formula is your gradient. Note it's as a ratio, not as a percent. And the other factors to consider with your gradient, the road could be on a level road, so your gradient is then 0, or it could be uphill, so uphill you will have to add I, plus I. If it's downhill, then you will have to subtract I. So obviously downhill you would expect a higher safe stopping side distance. So by subtracting I, your denominator is reduced, hence giving you a larger braking distance. So the overall safe stopping side distance will be greater. Okay. So I think I did slot in a simple example in here. So you can see the examiner could even base a calculation on the stopping side distance formula, but not the full formula. So what you have just seen is the generic formula for design stopping side distance or safe stopping side distance. Now in 2A you also had another formula, and you need to go back and highlight that formula, which is determining the safe stopping side distance based on your brake force coefficient. Go back and check now. This is your homework, to go back and check what is the formula to calculate the safe stopping side distance using the brake force coefficient formula. So again, you could be given a table, the design speed and the corresponding brake force, or the brake force coefficient could be given to you. And the formula is different to the generic formula that we just looked at. Making this point clear because in the exam, I did ask for the safe stopping side distance using the brake force coefficient, given the brake force coefficient. And many of the students used the generic formula and got it wrong. Although the answers may be very close, the final answer, but you haven't answered the question. You should be using the brake force coefficient formula if the examiner specifies brake force coefficient, given the brake force coefficient. So take note of that. Here you can see this appeared in a previous test, in fact last semester's test 1. This question appeared where you were given the braking distance. So now you got to be a bit careful, the braking distance. So the examiner, the focus was there only, on the braking distance. So you were given the D2 value, the braking distance value. And that distance was given at a design speed of 70 kilometers per hour, and that D2 distance was given as 68.082 meters. And from there, you were then required to determine the grade if the coefficient of friction F was given as 0.323. So if you look at the braking distance formula, you were given the speed, you were given the frictional coefficient value. G obviously is a constant, 9.81 meters per second squared. And you were required to find the grade I. And of course, you were given the braking distance, that the D2 value. You're given the braking distance. Simple. So all you need to do is make I the subject of the formula. There's your basic formula for your braking distance. And you're making I the distance, the subject of the formula, and from this solving for I. Note in the answer, final answer will be as a decimal or whatever, and then as a percent, you can see the question gave you there, very important, downgrade. Downgrade, therefore you can see the sign minus. Downgrade is negative. Okay, if it was upgrade, then it would have been positive. So you can interrogate that example in your time, go through it and verify, check whether the answer is correct. So yeah, typical calculation, simple 3-mark calculation based on stopping side distance. Okay, then briefly touching on the vehicle characteristics, and you can refer to your notes. There are some diagrams in your notes, typical dimensions, but basically when we look at the vehicle characteristics, we're focusing on elements like the length, the width of the vehicle, the height, the dashboard design, so forth. Especially if you have, for example, heavy vehicles like a single unit plus a trailer. Can you imagine if that, because of the length of that vehicle approaching maybe a T intersection and making a right turn at the T intersection, where does the right wheel at the back cross over? In other words, you have to trace the path of the rear wheel, the tracking path of the rear wheel. Very often it could even encroach onto the oncoming lane. So these are factors one would then take into account when designing an intersection, maybe a T intersection, and you generally design your design vehicle could then be a single unit plus a trailer. Right? So you have different templates, and from the templates you can then design to cater for the rear wheel tracking path. Weight also very important, and again on Tuesday I spoke about heavies, the number of E80, 80 kilonewton axle loads on your pavement, and what impact it has on your pavement. Okay, so now we're looking more at the structural design aspects, pavement design. I'm not sure whether you covered in 2B. You may have covered pavement design there, different methods. The South African method, the road TRH4, may have covered that. There are other methods as well, CBR method, group index method. So there's various methods. Those are more international methods. The TRH4 method is local conditions, research by the CSIR, Council for Scientific and Industrial Research. They're based in Pretoria. Visibility, certainly one needs to consider visibility, horizontal, vertical. So like I mentioned, dash design, you're sitting behind the wheel of a vehicle, how much of vertical and horizontal visibility you have. That comes under the vehicle design. Lighting, so you'll find that vehicle lighting is very important. Some vehicles have very poor lighting system. And recently there was some talk in terms of some of our heavies, like our trucks, for example, having very poor lighting, especially at the back, the rear. And motorists hardly see the heavies on the roads because of the poor lighting. And if you did some observation, you would find that some transport companies have addressed this problem by improving the lighting system on the heavies on the trucks. Okay, where even from a distance you can see some of these trucks have even decorated like a Christmas tree, but certainly has had a positive impact where you can see them from a distance. In terms of performance, yes, the power output, the acceleration, deceleration, and this aspect we will cover under traffic engineering in terms of power output, where the vehicle at a certain speed will be able to maneuver or climb a road with a certain gradient. Okay, so these are aspects that we will look at under traffic engineering. Okay. Some of you may be very familiar when it comes to power output of vehicles, torque of vehicles. So when you look at purchasing a vehicle, some of the factors you look at, some of you like speed, need for speed, so you check what is the output distance, 0 to 100 kilometers, 0 to 100 meters, but what time factor, 3 seconds, 4 seconds, 5 seconds. So you look at the output of the vehicle, the engine capacity, the torque. So, and that falls under the performance element. So that then brings us to skidding and stopping distances. So here we've incorporated the aspect of skidding now, skid factors that we're now looking at. So, and you can see there's a few points mentioned here in terms of deceleration. Deceleration, reducing of speed will generally take place. So there's various conditions. It could take place before your wheels lock. Okay. It could take place after the skid mark ends. And that also determines if the brakes were released and the vehicle was allowed to stop or roll. Third condition, after the skid mark ends, in this case, if the vehicle hits an object. The fourth one, after the skid mark, if the vehicle rolls over. And then you could have gaps in your skid marks. So in other words, where your vehicle's locked, but temporarily. So these are all factors that one would consider with regard to deceleration taking place. So in terms of the actual calculation, one would want to calculate what is the length of the skid mark, and the factors that one would take into account: the speed of the vehicle at the time your wheels locked, the friction that's developed between your wheel and your tire surface, the pavement, the grade of the road, again, whether you upgrade or downgrade. So those are factors one would consider to determine the length of skid marks. When it comes to the coefficient of friction or your drag factor, it's another terminology, you will see that there are various factors that one would have to consider, like, for example, the road surface, whether it's wet, whether it's dry, the texture, whether you're looking at an asphalt road or a concrete road, the geometric features. When we talk in terms of geometric features, you did cover geometric design to a certain level, up to a certain level in 2A. So when we talk in terms of geometric features, we're referring to the grades, how flat or how steep are your grades. Now we're referring to the vertical alignment. So the vertical alignment will cover your grades, how steep your grades are, whether it's upgrade, whether it's downgrade. Also covers your vertical alignment in terms of your vertical curves. So if you were linking one grade to a change of grade to another change of grade, you will connect that by means of a vertical curve. So smooth transition of your vehicle from grade A to grade B. You wouldn't draw a straight line there. Can you imagine a vehicle going up a stepped effect? It's certainly not good for any driver's tummy, isn't it? So that is why we link our grades by means of a vertical curve. And you know the basic principle behind vertical curves. It's a parabolic function, ax squared plus bx plus c. Therefore, you have a gradual rate of change of grade. So geometric features could cover that, could even cover your horizontal alignment, where we look specifically at the side distance, horizontal curves, radius of your horizontal curve. So whether it's a flat radius, sharp radius, short radius. So you've got a sharp horizontal curve, the super elevation. You would have covered aspects pertaining to super elevation, where you raise the carriageway cross section of the curve. So what happens? The outward pull or the outward effect of the centrifugal force whilst your vehicle is maneuvering the curve is counterbalanced by your super elevation, okay, as well as the frictional coefficient between the tire and your road surface. So these all fall under those conditions: vehicle operating conditions, the speed of the vehicle, size of the vehicle, the weight of the vehicle, and in terms of the tire factors, also the tire pressure, the loading on your tires, the size of your tires, the tread pattern. So these are all factors that will have a direct effect or impact on your drag factor or your coefficient of friction. And then the effect of grade, that is self-explanatory, whether it's upgrade or downgrade, expressed as a percent. Okay, could be a level road. Accuracy of speed computations, there's 4 points that's listed in your notes. And you can refer to your notes on page 15 at the bottom of page 15 and on the top of page 16, A, B, C, D, 4 points, which simply gives you some information on results that was obtained by computing your speed from your skid marks. So whether it was always lower than the speed, or whether it was speed accuracy, whether it was less than the speed. So those are some 4 points that's listed in your notes. And then with regard to safe stopping side distance, like I said, refer to notes and examples, and you have more examples under 2A. We looked at one example a short while ago where we used a certain part of your stopping side distance formula, mainly the braking distance D2, and you could see how a question could be phrased on the braking distance. So then a few questions or a few calculations pertaining to the skid effect, skidding of vehicles. And when it comes to the length of skid marks, you can see your basic formula for length of skid marks, D, given by u squared minus v squared, and in that formula u is the speed of your vehicle when your skid starts at the beginning of your skid, and v is where the skid ends, the speed of the vehicle where the skid ends, and it's measured in kilometers per hour or given in kilometers per hour. And note in the formula your length of skid mark D is in meters, so take note of these points. F in the formula is your average coefficient of friction, or the drag factor. So simple calculation at the bottom there, where you're given your u, which is the speed of the vehicle when the skid starts, given as 80 kilometers per hour, and then where the skid ends, the speed v is given as 15 kilometers per hour. You're given the coefficient of friction or drag factor as 0.31. So from there, you can quite easily calculate what is the length of the skid mark using the basic formula on the top. Answer is given there in brackets, 78.423 meters. I'll give you 2 minutes to quickly punch the values into your calculator and check or verify that you come up with the answer 78.423. You've got 2 minutes whilst I have some water.
Followed your cue. I followed your cue.
All right, that wasn't a difficult question. I'm sure you've all arrived at the answer of 78.423. If you didn't, then you need to go back to the drawing board and check where you're slipping up. Then we have the stopping side distance, or we also refer to it as the emergency stopping distance involving skidding. Now remember, we're talking about skidding here now. So don't confuse this with the safe stopping side distance formula that we went through previously. These are specifically pertaining to skidding. Okay, and you can see the formula they're given for the emergency stopping distance involving skidding, given as 0.278 u t p. That's your reaction time. We spoke about that a short while ago. Plus the u squared over 254f. So all these values, you know what u is, you know what f is, you know the reaction time. Well, of course, in a question that will be given to you, like the example at the bottom where you're given your speed 80 kilometers per hour, you're given your frictional value 0.31, given your reaction time of the driver and the vehicle lag time as 1.7 seconds, and from there you are then required to calculate the safe stopping side distance involving skidding, or the emergency stopping distance involving your skidding. And you can see again the answer is given 119.088 meters. I'll give you again 2 minutes to very quickly punch in the values to the generic formula for emergency stopping distance and see that you come up with the expected answer of 119.088. 2 minutes, go for it quickly.
Sir?
Yes, I can hear you.
So I just want to ask that the T value in seconds.
In seconds.
I've done it. I've done it off. I've got the answer. I'm just saying is will always be consistent with seconds. Must it always be put into seconds, and then your speed is always in kilometers per hour.
That's correct. The formula is derived based on those values and the units given. So in other words, based on the time value in seconds, the speed value in kilometers per hour. So it will always be like that. If the examiner tried to trick you and give you, for example, the speed in meters per second, then you will need to convert it in kilometers per hour because the formula calls for the speed in kilometers per hour.
Okay, thank you.
Okay, so that was the emergency stopping distance involving skidding. Now we take it a step further where we're still dealing with skid, and here we're looking at two different pavement surfaces. So how does the pavement surface then impact on the speed of the vehicle, or for that matter, if you were calculating the skid distance and so forth. So here we're looking at then the two different pavement surfaces, and you can see the formula. You can highlight. Remember at the last lecture, I did say to you that please, for your lecture today, have in your presence some writing material, your calculator, a highlighter if necessary, or if you need to jot down keywords or few points, you need to do a quick calculation like what we are doing right now. So please have some writing material and your calculator on hand. Okay, so I'm trying to make the session as interactive as possible, get you involved also, so that you don't fall off to sleep looking at or based only on the theory aspect, right? So we are now looking at some of the calculations pertaining to module 3. So the speed at the beginning of surface 1, whatever surface 1 is, you can see the speed formula given there, u squared equal to 254 FIDI. Obviously, then if you wanted to calculate speed, then it will be the square root of that. And the speed at the beginning of surface 2, okay, given there. And what are these D1s and D2s? So you can refer to the example there. So you had a vehicle that skidded on a bituminous surface, and then an adjacent asphalt surface. Okay, in that formula, should have mentioned the B and G, and finally came to a halt. So the average length of the skid mark D for the bituminous surface on the bituminous surface was given as 36 meters, and then on the gravel surface 12 meters. And from there, you're then required to calculate the speed of the vehicle at the beginning of the skid. And you're given the frictional coefficient of the drag factors for the bituminous surface to be 0.5 and for the gravel surface to be 0.6. So again, very straightforward application of formula. Simply applying the speed at the beginning of the gravel portion, and that gives you your U1, okay, and then the speed at the beginning of the asphalt portion. So the speed of the asphalt portion, so that gives you your speed 2, so U2. So bear in mind that the formula that's given to you is squared. So in other words, the speed U1 squared is given by 254, the frictional coefficient of the gravel and the drag distance dg. So to calculate the speed, then it will simply be the square root of that. So once again, I will give you 2 minutes to slot in the values, so put in the values, work out the square root, and you should get the speed at the beginning of the gravel section there to be 42.764, and the speed at the beginning of the asphalt section to be 80.005. Obviously, you would expect the speed at the asphalt section to be higher because you're moving from the asphalt section to the gravel section. So by the time you get onto the gravel section, your speed would have reduced drastically, and you can see it has reduced from 80.005 to 42.764. Okay, so you have a further 2 minutes then quickly to check, verify those answers. Okay, so I trust you did come up with the expected answers. If not, I suggest that you go back and check again. And if my memory serves me correct, I think the calculation is covered on Moodle, so you can check on Moodle as well. But please, again, I mentioned this at the last lecture, do the calculations on your own. Like I said to you, quite a few of the model answers or memorandums are posted on Moodle. And by simply referring to the model answer or the memorandum without doing the calculations on your own, firstly, defeats the purpose. And then secondly, it's not an effective way of studying for the subject. So I'm referring to the calculations, because bear in mind that in the test or in the exam, you will not be given the memorandum or the model answer. So get used to the idea of doing the calculation on your own and then checking the answers. And if you do, rather make a mistake now. And if you make a mistake now and you identify your mistake, and you look at the model answer and you see that you didn't come up with the expected answer, and you go back to the drawing board and you check where you went wrong, you will not make that mistake in the exam or the test. So please apply that procedure, work through the questions on your own, do the calculations on your own. So we finished on good time. We've completed the lecture period. So now the second period is for you to do your tutorial. And There's one tutorial that I have posted up here for you to do. So this is meant for you to do during the second period. So it's not a free period. So you will utilize the second period, the tutorial period, to handle this tutorial as well as a similar tutorial that's posted on Moodle. You will quite easily identify the tutorial on Moodle. And again, I'm saying to you that do the calculations on your own and then check your answers. Okay? So the second period is left entirely up to you to work on this question as well as another tutorial. If you go on Moodle, you will pick it up relating to safe distances pertaining to skid, okay, emergency safe distance. So you walk through those, and that should then bring you on par. And when we meet next week, we will then be looking at modules 4, 5, and 6. So those are the remaining modules pertaining to transportation systems. So you can see we're working at a fairly good pace. Obviously, more time will be allocated to traffic engineering, because traffic engineering, like I said, 90% is calculations, and there's some very challenging calculations under traffic engineering. And as I mentioned to you during the first lecture, traffic engineering will be covered in test 2, and test 2 assesses your graduate attribute, GA4. And again, take note that test 2 requires a sub-minimum of 50%. So you have to obtain 50% in test 2 to firstly get a DP, a course mark, to write the final exam. So if you don't make that 50% in your GA test, which is test 2, then unfortunately you don't qualify to write the final exam. So it's quite important. And that applies not only to GA4 in transport technology, but also the other subjects. So if you go through all your other subjects, you'll find that the other GAs, GA1, well, GA1 is in transport 3B. That's the other exit level subject, which if you haven't done, you will do next semester, 3B, TRTB 301. So, and then when it comes to GA 2, 3, and 5, 6, 7, 8, 9, 10, 11, those are covered in other subjects, and I think a few of them are covered in your project. So you need to satisfy all GA1 to GA11 to pass and to get your degree, okay? Because it has a direct impact on your registration with the Engineering Council of South Africa. So if you don't obtain all the GAs, EXA, which is the Engineering Council of South Africa, will not register you professionally. You have to be professionally registered if you want to practice. Okay. So yes, and that brings us then to the end of the lecture. As I said, you're now already on to the tutorial lecture, and you can make a start with this tutorial and then go on to Moodle. I did say to you, Moodle is your main Bible, your main academic hub, where all the tutorials are posted. All the course notes are there, the presentations are there as well, the study guide, the term planner, and as we move along, from time to time, any other notices will be posted on Moodle. But I did send you an email, so you also link to email. I have you grouped on email as well, and you should have diarized your test dates. So you should know that in the middle of March, which is not far away, we're almost the end of Feb now. So yeah, this is the end of Feb. On Monday is the end of Feb. So March, if you look middle of March, 15th of March to be more precise. The test 1 is scheduled for the 15th of March. It's a short test, 1-hour test, not a long test. And like I said, normally with test 1 covers a fair amount of theory, because most of your theory is covered in transportation planning and transportation systems. And of course, the calculations that we've gone through now in transportation system. So to be on the safe side, allow up to 60% theory. I said to be on the safe side, Who knows, you may get 50% theory, 50% calculation, 50-50. But just to be on the safe side, I'm saying 50-40, 50 theory, 40 calcs. When it comes to test two, you could expect 100% calculations. Okay? Traffic engineering. So that gives you a good overview of the course now. So start working towards test one. Not far away, just over 2 weeks away, 2.5 weeks. So start doing some work, go through some of the theory. At this stage, we are still expecting the test to be held on campus. As you know, that assessments, this is department and faculty ruling that the assessments will be face-to-face on campus. But again, I'm saying nothing cast in stone. We're not sure what the next 2.5 weeks holds, so we will cross that bridge when we come to it. But for now, we expect to write test 2 on campus. And that was one of the main reasons why we went online, because also of the volatile situation, the uncertainty at present. I mean, you know, campus is closed. So if we had finalized face-to-face lectures, we would have lost out on already 1 week of lectures. So I think glad that we went this route. At least your lectures will be completed. I mean, there's even a possibility of you losing the whole semester. But you, like I said, with the online, you've overcome or avoided that option. So certainly it's been to your advantage. So we will have to just wait for decisions coming from management. Management will notify you as well. So look at the reliable sources. Don't look at all the fake messages. You know the reliable sources. So, and you'll take it from there. Okay, any questions before we sign off then? Or before you get onto your tutorial? Okay, if there's no questions, then you can then go on. Like I said, it's not a free period. It is a tutorial period. You can commence with this tutorial. You shouldn't have a problem. I've done an example already now, so it's just a matter of values that have been changed. It's a matter of application of formulae. So straightforward calculations. Okay, thank you. We'll meet then on Tuesday.